I'd like to tell you a story. In 1857, not far from here, a man by the name Carl Zeiss sold the first ever commercially produced compound microscope. It was a fragile, bulky, an expensive piece of equipment, but it would still grow to become the backbone of modern medical diagnosis. Fast forward 150 years, and we have modernized this device into a fragile and even bulkier piece of equipment that can go for upwards of $40,000. Yet, it remains critical, both to medicine and science alike. Compare this to the evolution of the calculator. We went from a bulky and slow machine to a pocket-sized computer in the same amount of time. But why is it that the calculator evolved so dramatically, while the microscope did not? Well, we learned how to change the fundamental building block of the calculator, from the mechanical gear to the transistor. But for the microscope, the building blocks are the optics, and these have not changed in their way of manufacture from the grinding and polishing of transparent material that was already being done by the ancient Egyptians. This limits us. It represents a wall that keeps us from being able to produce more compact and inexpensive optical instruments. But not anymore. The device in my hand is about as thin as a piece of paper and costs only a few cents to make. Yet, it is able to manipulate light as if it were a complex array of traditional optical components. Instead of relying on the properties of a material like glass, this uses an array of nanostructures on its surface. A single nanostructure is able to change the light that passes through it a tiny bit, but combined, they allow us to achieve very complex behaviors in a very compact space. Devices like this are manufactured using the same technology that we currently use to produce computer chips, which means that the same assembly line that currently manufactures your smartphone could now be used to produce camera optics, contact lenses, or even to turn something as complex as a biological microscope to a device that fits in the palm of your hand for the price of a cup of coffee. But this is not the end of the story. This is but the beginning of what is possible when you break down the wall of ultraflat optics. Thank you.